Today we're going to look at gas stoichiometry at STP. Previous to this, we've been working with combined gas law and the ideal gas law. Today we're going to be working with STP, which stands for standard temperature and pressure. The standard pressure is at 1 atm, and the standard temperature is 0 degrees Celsius or 273 K, which is equivalent to 0 degrees Celsius. Here we're going to start with this problem. What is the volume of 44.01 grams of CO2 at STP? We have three things given to us. We have N moles, which we can convert from the grams. We have the temperature and we have the pressure. So we're actually going to use the ideal gas law for this one because remember it has four variables and we're trying to find the fourth one, the volume. So let's start off by converting the 44 grams to moles. Okay, in 1 mole of CO2, there are 44.01 grams. So this is equal to 1 mole of CO2. So now, using PV equals nRT, we have the pressure, which is 1 atm, which we got from the standard pressure. We're trying to find the volume. The mole is 1. R is 0.0821. And the temperature is 0 degrees Celsius or 273 Kelvin. So we're going to multiply the 1 times the 0.0821 times 273 and divide it by 1 to get a volume of 22.4 liters. Now this 22.4 liters is a very unique number that we want to talk about. It's called the molar volume. The reason it's called the molar volume is any gas, 1 mole of any gas at STP will have the volume of 22.4 liters. For example, 2.02 grams of hydrogen, which is 1 mole of hydrogen, at STP would end up having the exact same numbers being plugged into PV equals nRT. So the volume of 2.02 grams of hydrogen, which is 1 mole, is 22.4 liters. 4 grams of helium would be equal to 1 mole. Again, at STP, all the numbers in PV equals nRT would be the same. Again, so 22.4 liters. So we're going to use this number to help us solve problems. Okay, so now we have 77.8 grams of C3H8, which is propane, reacted with excess oxygen at STP. How many liters of carbon dioxide were produced? Okay, now this is stoichiometry. We don't have, we want to convert from C3H8 to oxygen, so we have to use stoichiometry and the mole-to-mole ratios. So we're going to start off with 77.8 grams of C3H8. The first thing, like we had stoichiometry, is we want to convert that to moles. So we want that to be 1 mole of C3H8. So we have to add up on the periodic table the molar mass of C3H8, which is 44.10 grams. Then we're going to do a mole-mole conversion from C3H8 to CO2, because that's what it's asking us to go to. So from 1 mole to 3 moles of CO2. And then finally, it's not asking for moles of CO2, it's asking for liters. And we know that in 1 mole of CO2, there's 22.4 liters as long as we're at this STP, which we are at. So I can put 1 mole at the bottom and 22.4 liters at the top. Now I just got to use my calculator. Take 77.8, divide it by 44.1, multiply it by 3, and multiply it by 22.4. And we get the final answer of 119 liters of CO2. Okay, that's gas stoichiometry because we're converting to liters instead of grams down here. So this mole to liter step is in place of the mole to gram step that we had in stoichiometry to begin with. Let's try one more problem. Okay, using the same equation, what volume of oxygen is needed to react with 22.8 grams of C3H8 at STP? Now, I wouldn't have to always use C3H8. It's just the two problems I happen to pick. So we're going to start off with 22.8 grams of C3H8. Anytime I'm doing stoichiometry and I have grams, the first thing I want to do is convert to moles. So again, using the molar mass is C3H8. Then, since it's not asking for C3H8, we want to convert from it to what it's asking for, which is oxygen. So the 1 mole is C3H8 on the bottom, and 5 moles of oxygen on top. Again, because we're at STP, we can use the fact that it wants volume. We can use that in 1 mole. There is 22.4 liters. And then we're ready to use our calculator and do the math. By multiplying and dividing, you should come up with 57.9 liters. Okay, check your work and see if you get the same answer. Again, this is a gas stoichiometry, converting from one gas to another at STP.